Alright, hello everyone, and welcome to the 12th video. This video is on tracking problems again. This is part 2, and this part is meant to be watched after you've watched the video on if statements and truth tables. We'll be using Boolean expressions and if statement logic in this video. Along with going over tracking problems, which is related to homework number 4, and this video is going to be helpful for completing that homework. We're going to be going over a few other topics in this video, which you can see in the multi-line comment in green. Specifically, we're going to talk about some other things that we've been kind of avoiding in our scripts that we'll be adding as little tools to our tool belt, and that they're not quite topics big enough for a video on their own, so we're throwing them in here. So what are they? We're going to talk about imports. You'll see we have our first import at the top of this script that says import math. We'll be talking about some of the math functions that are available. We'll be discussing casting. We briefly did in class. We'll be talking about it again in this video. We're going to talk about something called short circuit evaluation, which is related to how the interpreter basically uses a shortcut to evaluate Boolean expressions. And then we're going to talk some more about the print function. We've used the print function to print the values of variables, but it can do a lot more, a few more tools. So we're going to be talking about these things as well as going through just a single problem today. Some of my recent videos have been kind of long, so hoping this one is a bit shorter. If you look at homework 4, and I recommend you do that before you move on, just to kind of see what kind of problems you'll be doing. You'll see some kind of problem that looks like this. This is a combination of what we did in part 1. You can see we annotated these problems here. We had our little notes. So it's a combination of this and working with if statements, and I guess truth tables, since we've got our Boolean operators, or, and not. When you first look at these problems, they're going to look a little intimidating, and this the gist of it is that this is not going to be as hard as it looks to be, because one thing we have to remember with if statements is that when we have these blocks of if-else statements, you only ever run one block of code per if structure. So we have one if-else structure from here to there. So that means regardless of how these numbers work out, we're either going to run this big if statement or we're going to run this else statement. We never run both. So whenever you see something like this, know that you're only going to be running maybe a fourth of the code that you see. You're going to end up skipping most of these lines. The same goes for this if-else structure. If this first if statement is true, well, that means we're only going to run one of these blocks, either this if block, this else if block, or this else block. And same goes for any nested if-else statements inside those statements, inside those blocks. So you end up skipping a lot of lines here, and one of the keys to doing this is making sure that you know what needs to be skipped and when the function is done. So this is going to be an example for how to do these types of problems. First off, we'll go through our topics here as we also work through this problem. What is going on here when we say import math? Import statements happen at the very top of our files. That's where you should put them at least. You can see that you could have a lot of imports depending on what kind of things you're using. And these are other scripts that are included in the public library, or sometimes you could find ones that other people have written to use. Oh, here we go. There's the math module in this project. In order to use the module, you have to say import and then the name of the package or the name of the script, whatever it may be. I guess this would be the name of the script. We'll talk about packages maybe another time. we're just going to use one function from this math module today, called the sqrt function, which is the square root function. We can look this up too by Googling. We could look up Python math module, and we could click on the first link, and it's going to take us to something called the documentation for this module. There's a bunch of things that you would find in math. You got combinatorics, you got factorials, you got greatest common divisor, least common multiple, and many other things. There's stuff here for logarithms, for exponents. There's going to be stuff for trig-based equations, and constants that you could use. So in this class, we don't really do a ton of math, but we will use some of these things. Some are pretty useful, just commonly. Specifically, the ones that are quite useful. If you ever do any basic trig, you need some basic trig if you ever are calculating anything that has arc. That's like if something is being affected by gravity, probably need some trig to calculate that in a game. So, you know, projectiles in a video game or something like that. Where's actually the thing I'm looking for? I guess where's square root? It's a basic one. Oh, there it is. It's tucked here next to power. There is a function for computing powers. We already have an exponent operator, so you don't really need this function, but you could use it if you wanted. But here's our square root. We just want the simple square root. If we click on the square root, it'll tell us about this function. At least a little bit. Look, this is all they give us. I guess they assume you know how square roots work. Most important thing being that they give us a decimal number, a fractional number. So we'll look back at that later when we encounter that on line 18. So the instructions for this problem is that we're trying to find the values of a, b, and c by the time they print down here in this print statement. Now for a lot of these problems, we could just, if we have it in code, we could just run the code and see what it prints, and we have our answers. So this type of problem is really not about finding the answer, it's about how do you get the answer. How do we end up with a being 8, b being 64, and c being 4? One step at a time, that's our answer. All right, first line, we'll start here. This is also something I didn't really include in my list here, but this is a shortcut. Python allows you to do things quickly. It's the best way to put it. It's a little shortcut for assigning A to 1, B to 2, and C to 3, instead of doing each of those in one line each. So you can do something like this. And we'll see something like this also when we work with functions and return multiple values, and maybe when we're working with collections. So our first real line is here, where we have this big ol' b plus equals statement. So what's going on here? We have some parentheses, so we've got to follow PEMDAS. Maybe we'll make a note here. Follow PEMDAS. We don't have any cops or bops in this expression, but we do have some functions. So if we're following PEMDAS, we go to the innermost parentheses first, and we've got an a minus c here. But that's not even the first step. If you remember the last tracking problems video, the first step is just to rewrite this shortcut so that we don't mess it up, right? Because this is the same as b plus everything on the right hand side. And then the next step isn't to do any math yet either. It's just to it's only to do some substitutions. Okay, we don't actually need these outer parentheses since this is all a single value. So we'll just take it out. Let's write our a and c values. 1 minus 3 raised to the second power. Okay. Next, what do we do? Well, ignoring all these function things, we can do the math on the inside. We'll end up with minus 2 raised to the second power on the inside of our expression here. All right, well now we gotta use our square root function. Oh wait, no we don't. We gotta do minus 2 raised to the second power, which is 4. Okay. Now we gotta use our square root. In this case, we're just going to get 2.0. It's going to be some easy math, right, since it's a perfect square. This function here is new. This is casting what it looks like. We're actually using a function called int that's in the public library to forcibly change this to a whole number. So anytime you cast something, it's just like integer division. If there's any decimals, we're just going to drop those decimals. So we end up with b is equal to 2 plus 2. All right, so after all that, b is just 4. Okay, a little bit of lag. Next, we move on to this line. C minus equals all this. So first thing we do is we rewrite this. So I just copied that right-hand side, and I made sure to rewrite it as C minus all of that and to use the parentheses. Very important step. All the time I see people skip that step, and then they do part of the distribution wrong. All right, now we're substituting for A, B, and C. And then now we can do the parentheses first. And inside of here, we have a lot of stuff. We've got exponents that we need to evaluate first. So first we have 3 raised to the second power. We get 9. And I'm still only doing one step at a time. Could do more, but I don't want to make mistakes. Then we'll get 81, which is 9 raised to the second power. Hey. Okay. Now what? Well, 3 goes into 81, so this whole modulus just becomes 0, which is not very exciting. We didn't end up with any very large numbers. So C is going to be 2 after all that. Just one step at a time. Nice and slow and boring and not fast. But that's how we make sure that we do these right. All right, so here's our first really new statement. Now we aren't just working with P's and Q's, and we don't just have a single conditional expression. We actually have 2 conditional expressions separated by an or. So if you followed the truth tables video, and if you did that truth tables homework number 3, you should know that anytime you have an or, you only need one of these expressions to be true in order for the whole thing to be true, in order for us to evaluate the inside of this scope. So if we're going to evaluate this, one of these expressions has to be true. So I'll also write these in the notes as little comments, because we could get these wrong too if we try to do too much in a single line. First we substitute. So C is 2 now, B is 4 now. I'm going to write triple dots here. So 2 raised to the second power is 4. Oh look, 4 is equal to 4. So that is true. And this brings us to something called short circuit evaluation. Now we don't actually care what the second half of this is. We could do it. Would it be true or not? I don't know. I never actually checked. Is 1 greater than 4 minus 2? Well, no, so this would be false. But it doesn't matter that it's false because we already have one true, and anything that's true or false is true, right? That's how the or operator works. So when your computer is evaluating this expression, it doesn't care either. As soon as it finds a true and then an or, it knows that the whole thing is going to be true, so it will never actually evaluate this expression. And we know this is true because we could do something really silly, like what if we do something like this? We could, divide by 0 here. And if this is true, if there is short circuit evaluation, we shouldn't even get an error. That means that this expression is not even evaluated. Otherwise, we should get a 0 division error. So why don't we try that? Yeah, I ran it. Same result. Almost looks like nothing changed, but I did run the program. So this is never actually run at all, which is proof of that. Whoops. So short circuit evaluation is when the interpreter only reads the first expression if it is true when using the OR Boolean operator. And there's another way we can use short circuit evaluation, and that's if we have an AND. Secondly, the interpreter will only read the first expression if it is false when using the AND Boolean operator, since it will already know the Boolean expression will have to be false regardless of the second expression. In other words, when we have an and we have at least one false, no matter what, it's going to be false. So that means that if the first expression is false, we don't need to check the second one. It's a waste of time. So yeah, don't be extra and be doing a bunch of math you don't need to. Just do the first part. Now, if we're using an OR and this first part is false, well, then we're out of luck. We got to check the second one, whether it's true or false, because then it matters, right? If it's false, then the whole condition is false for that if condition. If it's true, then it's going to be true. So it could change what is evaluated. In this case, since we did get true, then this tells us a number of things. One, if we zoom out here, well, we know we're going to evaluate the body of this if statement, which is everything from here to there. So we're running all this, which means we're not going to run any of this. So that means that C will never be set to cat or dog or changed here, right? We could effectively cross this all out. And if we were working on paper, then I would encourage you to cross out this section once you know that we are running the if statement. Okay. Yeah, so let's move on. I guess there's one other thing to remember. When we are doing these statements here, we are not actually assigning any values. We never changed the value of C or B or A in these expressions, right? There's no equal sign, right? This is checking for equivalence here. It's not assigning anything. So we have to be very careful. When you are writing code, if you're using an if statement, you should use the double equals. If you do not, that means that you're assigning something. And technically Python will allow you to use a single equals. However, it's probably not what you meant to do. And in fact, it's not going to let me to do this here because of the way this is set up. But there's ways to use a single equals, but we generally don't want to use them. Okay, let's evaluate this next line. We've got another stinker to figure out. So let's follow our steps. Right, this line, when we rewrite the shortcut, is equal to this. Then we do our substitutes. What's B? B is 4, C is 2, A hasn't changed. So A is still 1. Okay? So since I've forgotten, right, it's hard to remember these things, I'll just write a little note to myself. Reminder, A is 1, B is 4, C is 2 at this point. That way I don't have to keep scrolling or accidentally use the wrong number in some way, which we don't want to do. We're aiming for precision here. Alright, we did our substitution. Now we follow PEMDAS. Let's see the innermost parentheses. There's some multiplication. One step at a time, really boring. Once you do feel confident with this, if you want to skip a step, you can. But I'm telling you that, like, if I want to make sure I get something right, I'm not going to be skipping steps, even though I really probably don't need to. All right, so we get B is 16. All right. Next, we evaluate this if statement. Okay, so we have 16 mod 2 and seeing if it's equal to 1. Well, 16 mod 2 gives us no remainder, so that's not true. That is false. So that does mean we're not running either of these lines, and we're going to skip to check the else if statement. Okay, well, this one we have a not operator, so we should be careful there. We have not B is 16 now, 16 greater than 10, or what do we have here? We've got a compound Boolean expression here, and what is C? Is C still 2? Yes, and is 2 greater than 0? All right. If we're following PEMDAS, it really doesn't matter which expression we do first, but might as well go left to right. So on the left expression, we have not 16 greater than 10. So the way I like to think of this is just evaluate 16 greater than 10 and then apply the not after that, because we're going to get a true or false value for using this greater than symbol. So 16 is greater than 10, so that's true. So we have not true, or the right hand side. So that means we have false on the left hand side. So that means we do need to evaluate this right hand side. It matters, right? Okay, so we got to see if this is true or not. And let's see, is 1 less than 0? No. And we don't even care about the second part, right? We have a false and, which means no matter what this is, and it is true, but no matter what, it's going to be false. So we actually have a false or false, so the result is false. So that means we're not running this else if block either. We're running none of these statements. So that means we're doing the default. We're following the else. Right? No condition to check, so we just straight up change A. So A is now going to be adding 7 to itself. So it's now 8. Let's see, let me rewrite everything. I'll do this again just to keep track. What B is now 16. I think C is still 2. Let me make sure. Yeah. Okay, C is still 2. All right, so now we're to this last part right here. I got another if statement to evaluate. So we're just going to copy this, and then we'll do some substitutions. A is 8, B is 16, C is 2. Let's do all my C's. Let me do all my B's. Do all my A's. A is now 8. Okay, that's step 1. Let's copy that again. Remember, copy paste is your friend. You should use it whenever you can because it saves time. All right, this left-hand side, we get minus 10. I'm going to just do this at the same time. What is that, minus 22? Wait a second. Is minus 10 greater than minus 22? I guess I didn't need to rewrite this part here, right? Because it's an or. Because this is true. And since it is true, we don't care about the right-hand side. The result is true. So that means we're going to evaluate this line and not the else. There is something tricky here, or sneaky, rather. This C plus equals 2 is not part of this else statement. So that means that we are going to run this because we're in this body of this else, and we have to run every part of this else statement. So even though we run this if, we'll only skip this else statement. We don't skip this last line. So once we finish running this line for B, we do have to add 2 to the result of C. Okay, so let's evaluate this line. This line is, I got another shortcut operator, so we follow our steps. We're going to substitute B in A in all the variables. We do have something new here that says abs, which we'll talk about in a second. 2 minus 8 minus 16 times 2 mod 5. Okay, what is this abs thing? This is another function that stands for absolute value. So also for math, anything that's an absolute value, we end up taking the positive, whatever that result is. That's all it does. And this is one of our built-in functions. So if we go and check out the built-in functions and find that list, I think this this page is linked on Google Classroom. We could find the abs function. There it is, very first one. Returns the absolute value of a number. And it works with integers or floating point numbers, which are decimals. Cool. All right, so let's see, we do our innermost parentheses first, which is the absolute value. What do we get? 2 minus 8 is minus 6, minus 16 is minus 22. Yeah. So the absolute value of minus 22 is just 22. Ooh, we're gonna get some big numbers here because we've got a 22 squared. I don't know my 22 squared values. Let's do some sloppy math here. Wow, really sloppy math. Let's try that again. 4 and 4. I mean, probably if you know your tricks, you could do this in your head, but we'll just do this here. 484 is what I got. 484 mod 5. Great thing about modulus is it takes very big numbers and makes them pretty small usually, because 484 mod 5 is just going to leave a remainder of 4. So we'll end up with B, taking the old value B, multiplying it times 4, which is 64. And lastly, we skip this else line. Just like I said before, we got to run this C line, this sneaky C line, where we take the old value C, which is 2, and add 2 to it. So we get 4. So I believe we got what we expected, right? A is currently 8, B is 64 now, C is 4. So we did get what is being printed, so we know we did it right. Hooray. So if we look back at this problem, just take a look at what all we skipped. So we skipped this part of the if statement, we skipped this part of the else if statement, we skipped this else statement, we skipped this entire else block, which includes a nested if else statement. So you do skip a lot of lines. You still do a good bit of math, but it's not like it's everything, right? And then we print. Before this video ends, I want to show us how to maybe check our work along the way using print statements. Like, let's say we wanted to see what happened, or check our work along the way. Something we could do is something like this. We could say print, and in text we could put something like some formatting for B. What should we put though? Since this is on line 26, and the lines will change if we add more lines before this, but we'll just say this for now. I'm going to say that say by, line 26, B is, and then we're going to put a comma, then B. So what this is going to do is we're going to print this string value, and then we're going to attach B at the end of the string. So these are doing something called concatenating. Concatenation. Concatenation is when you combine two strings into one. So we're converting B to a string and then smushing it into the other one. And that's all done behind the scenes by Python. Now this isn't going to look exactly how we expect, so pay attention. We have one space here, and then we want to put our number. Let's see what that looks like. We get this extra space in our output. And the reason for this is, if we look up the print function, in the print function, we've actually got, how many parameters is this? Well, this could be multiple, but if we assume this is 1 right here, then that'd be 1, 2, 3, 4, 5. 5 possible parameters. The thing that makes this different, that it's not always 5 parameters, is that the last 4 are all optional. And these are actually all, like when you don't put any data for these last 4 parameters, that means you're using the default values for these parameters. Okay, so one of these parameters is specifying how your objects are separated. So the default is actually a space. It's hard to tell, but this is actually a space. So since the default is a space here, it is adding a space, even though we already included a space. So we have options here. We could delete that space, and it adds a space for us so that it looks better. A second option, we could keep the space, and we keep B, and then we just say, actually, I want my separation to be something called the empty quotes, meaning that there's nothing being put between my objects. And you could use 2 apostrophes, you could use 2 quotes, and it's going to work the same way because you can use either quotes or apostrophes for strings. And we also get the correct format for this when we use it. So up to you. But there's options for formatting using the print statement. The other option we have is the end value. So by default, it actually moves things to the next line. If we don't do that, if we say, actually, let's set my end value to nothing, we're going to see that this line here, when we print, is going to be jammed next to the 864 line. So it's going to look like B is equal to 48 space 64 space 4. Because we don't have a new line character. So we either change that to something else, or we just keep it as a new line. We could even set it to what the new line character is, which is the /n, which is the default value, but we could set it like that if we want, and then we get what we originally had. As for these last 2, I don't think we'll be using these in this class, or at least I'm not going to be teaching them. So maybe if you're interested, you could look at examples of how you would use these, but generally speaking, I don't need to use these for this function. So you could kind of go through this problem here and have some lines like this. Let's do something similar after this C value. We could say by line 34 and just say C. See, we really don't need this second stuff. I'm going to delete this for this. We could say C is 2. So this is one way of tracking how values change as we go through code. There is other ways to do this called debugging, where we're essentially going to be doing the same thing but without using a print statement. But these are very useful for programmers to identify how the data is changing, where the code is being run, and stuff like that. Yeah, and that's it for this video. In the next video, we're going to be talking about functions. Very important topic, which you'll need for the first project. And once we finish talking about functions, we'll talk about the project itself and have a video on checker as well. So stay tuned for that.